6161. In what part of the atmosphere does most weather occur? A. Tropopause. B. Troposphere. C. Stratosphere. The correct answer is B. The troposphere is the lowest layer of the Earth's atmosphere, extending from the surface up to an altitude of approximately 8 to 15 kilometers, 5 to 9 miles, near the poles, and 18 to 20 kilometers, 11 to 12 miles, near the equator. It is the layer in closest contact with the Earth's surface and contains the air we breathe. Several key factors contribute to the troposphere being the primary region for weather phenomena. One crucial factor is the temperature profile within this layer. Generally, the temperature decreases with increasing altitude in the troposphere. This characteristic is known as the lapse rate. As air rises, it expands and cools, leading to the condensation of water vapor and the formation of clouds. The temperature gradient in the troposphere helps support the vertical mixing of air masses, promoting the development of weather systems. Another critical aspect of the troposphere is its interaction with the Earth's surface. The surface heats up during the day, warming the air in contact with it. This warmer air becomes buoyant and rises, creating updrafts. As the warm air rises, it can lead to the formation of convective clouds, thunderstorms, and other localized weather phenomena. Furthermore, the troposphere is the layer where most of the Earth's moisture resides. Water vapor plays a significant role in the formation of clouds, precipitation, and other weather-related processes. The troposphere contains the majority of the atmospheric moisture, allowing for the condensation and release of water vapor as rain, snow, or other forms of precipitation. Lastly, the troposphere is strongly influenced by various large-scale atmospheric circulation patterns, such as jet streams and global wind patterns. These patterns help transport heat, moisture, and energy across the Earth's surface, contributing to the formation and movement of weather systems. Overall, due to its proximity to the Earth's surface, its temperature characteristics, interaction with surface heating, abundance of moisture, and involvement in large-scale atmospheric circulation, the troposphere is the primary region where most weather occurs. It is a dynamic layer that fosters the development of clouds, precipitation, storms, and other atmospheric phenomena that shape our daily weather patterns. 6173. What are the standard temperature and pressure values for mean sea level? A. 15 degree F and 29.92 Hg. B. 59 degrees C and 29.92 MB. C. 59 degree F and 1013.2 MB. The correct answer is C. The standard temperature and pressure values for mean sea level serve as reference points in meteorology and aviation. These values provide a baseline for comparing and interpreting atmospheric measurements and weather data. The standard temperature at mean sea level is considered to be around 59 degrees Fahrenheit, 15 degrees Celsius. This value represents the average temperature observed at sea level under normal conditions. It serves as a reference for comparing temperature measurements at different elevations and locations. By using this standard temperature, meteorologists can assess deviations from the norm and make accurate comparisons across different regions. Regarding pressure, the standard atmospheric pressure at mean sea level is approximately 1013.2 millibars, MB, or 1013.2 hectopascals, HPA. This value represents the average pressure exerted by the Earth's atmosphere at sea level. It serves as a standard reference point for measuring and calculating atmospheric pressure variations at different altitudes and locations. The standard pressure of 1013.2 MB is often used as a benchmark in meteorology and aviation. It allows for consistent comparisons of pressure measurements, especially when analyzing weather systems, pressure gradients, and the behavior of high and low pressure systems. Additionally, it aids in the conversion of pressure measurements between different units, such as millibars, hectopascals, inches of mercury, inHg, and pounds per square inch, psi. It's important to note that these standard temperature and pressure values for mean sea level are based on average atmospheric conditions and are used as reference points for comparison and analysis. In reality, Actual temperature and pressure values can vary significantly due to factors such as local weather patterns, geographical location, and altitude. Nonetheless, the standard values provide a consistent basis for assessing and interpreting atmospheric conditions across different locations and elevations. 6162. Which is the primary driving force of weather on the Earth? A. The Sun. B. Coriolis. C. Rotation of the Earth. The correct answer is A. The Sun emits vast amounts of energy, particularly in the form of solar radiation. This energy is essential for driving the Earth's atmospheric processes and weather phenomena. When the Sun's rays reach the Earth's surface, they heat the land, oceans, and atmosphere. This differential heating creates variations in temperature, which in turn generate atmospheric circulation patterns and weather systems. The Sun's energy is responsible for initiating several key processes in the Earth's atmosphere. It causes air to warm, expand, and rise, leading to the formation of updrafts and convective currents. These movements, combined with the rotation of the Earth, create atmospheric circulation patterns, such as convection cells and global wind systems. Solar radiation is also responsible for driving the water cycle, which is crucial for the formation of clouds, precipitation, and other weather-related phenomena. The Sun's heat evaporates water from the Earth's surface, lifting it into the atmosphere as water vapor. As this moist air rises, it cools and condenses, forming clouds and eventually leading to precipitation. Furthermore, the Sun's energy provides the primary source of heat that fuels atmospheric disturbances and weather extremes. It powers the development of thunderstorms, hurricanes, and other intense weather events. The differential heating of the Earth's surface by the Sun also contributes to the formation of high and low pressure systems, which play a fundamental role in shaping weather patterns. In summary, the Sun's energy and radiation serve as the primary driving force behind weather on Earth. Its heat and light initiate atmospheric processes, such as convection, circulation, and the water cycle, which are essential for the formation of weather systems and the overall dynamics of Earth's climate. 6163. The average lapse rate in the troposphere is A. 2.0 degrees C per 1,000 feet. B. 3.0 degrees C per 1,000 feet. C. 5.4 degrees C per 1,000 feet. The correct answer is A. The lapse rate refers to the rate at which the temperature changes with increasing altitude in the Earth's atmosphere. It provides insights into the vertical temperature profile and helps us understand the stability and dynamics of the air. In the troposphere, the average lapse rate is approximately 2.0 degrees Celsius per 1,000 feet of ascent, or 3.6 degrees Fahrenheit per 1,000 feet. This means that, on average, the temperature decreases by about 2.0 degrees Celsius for every 1,000 feet of elevation gained within the troposphere. The troposphere is characterized by a decrease in temperature with increasing altitude. This decrease occurs due to the expansion of air as it rises and experiences lower atmospheric pressure. As the air expands, it cools adiabatically, without exchanging heat with the surroundings, resulting in a decrease in temperature. It's important to note that the actual lapse rate in the troposphere can vary depending on various factors. One such factor is the region or geographic location. For example, in some regions, the lapse rate may deviate from the average due to local weather patterns, topography, or other geographical influences. Another factor is the time of year. The lapse rate can vary seasonally, especially in regions with distinct seasons. For example, during summer months, convective processes may dominate, leading to steeper lapse rates due to the vertical mixing of warm and cool air. In contrast, during winter months, stable air masses and temperature inversions may result in shallower lapse rates. Weather conditions can also influence the lapse rate. In the presence of moisture and condensation processes, the temperature profile can be modified, leading to variations in lapse rate. For example, when water vapor condenses into clouds, it releases latent heat, which can affect the temperature lapse rate. It's important to remember that while the average lapse rate in the troposphere is approximately 2.0 degrees Celsius per 1,000 feet, actual lapse rates can deviate from this average due to the aforementioned factors. However, the average lapse rate provides a useful reference for understanding the typical temperature changes that occur within the troposphere as we ascend through the Earth's atmosphere. 6166. If the air temperature is plus 6 degrees C at an elevation of 700 feet and a standard, average, temperature lapse rate exists, what will be the approximate freezing level? A. 6,700 feet MSL. B. 3,700 feet MSL. C. 2,700 feet MSL. The correct answer is B. To determine the approximate freezing level, we need to consider the standard temperature lapse rate. The standard temperature lapse rate in the troposphere is approximately 2.0 degrees Celsius per 1,000 feet. Given that the air temperature is plus 6 degrees Celsius at an elevation of 700 feet, we can calculate the difference in temperature between the current elevation and the freezing level. To determine the difference in temperature, we first need to find the difference in elevation between the current altitude, 700 feet, and the freezing level. Since the lapse rate is 2.0 degrees Celsius per 1,000 feet, for every 1,000 feet increase in altitude, the temperature drops by approximately 2.0 degrees Celsius. So, the difference in elevation between the current altitude and the freezing level is 6,700 feet to 700 feet, equals 6,000 feet. Now, we can calculate the temperature difference by multiplying the lapse rate by the difference in elevation. Temperature difference equals 2.0 degrees Celsius / 1,000 feet times 6,000 feet equals 12 degrees Celsius. Since the initial temperature is plus 6 degrees Celsius, the freezing level occurs when the temperature drops to 0 degrees Celsius. To find the freezing level, we subtract the temperature difference from the initial temperature. Freezing level equals 6 degrees Celsius. 12 degrees Celsius equals minus 6 degrees Celsius. Therefore, the freezing level occurs when the air temperature reaches minus 6 degrees Celsius. Given that this temperature occurs at an elevation of 3,700 feet, which is the freezing level, the correct answer is 3,700 feet MSL.